Hello, welcome to Chemistry Buds. Today I will discuss the simple Eutectic system. In the last video we have discussed the two component system and different keywords like the congruent melting point, incongruent melting point, eutectic, peritectic, etc. So today we will discuss details about the eutectic and its formation, what is eutectic. Then let us review the two component system again. So according to the Gibbs phase rule, we have F is equal to 2 plus C minus P, and for two component system the F max is equal to 2 plus Q minus 1, that is 3. So the F max at phase 1, when number of phases is minimum, that is 1, the degree of freedom is maximum. So these three independent variables are corresponding to the temperature, pressure and concentration. Okay. So the plotting of this three component graph, three-dimensional graph, and its interpretation and study is difficult. So we have to keep one of the variable constant and take two variables at a time for the study, and that will be the condensed phase rule. So there are so many possibilities, that is T and P are variable when concentration is constant, and P concentration when T is constant. Also the T concentration and P constant. Okay, so we will consider the T concentration, P constant. So you have to keep the pressure constant. So this is also possible. There are three possibilities. Out of these three possibilities, we will consider the temperature, concentration are variables when pressure is constant. So your condensed phase rule will become F is equal to 1 plus C minus P. So this will be the condensed phase. Okay. And when we are considering the temperature and the concentration as independent variables, given the pressure constant, also in the system there will be no gaseous component, because when there is no gaseous component, the system will be independent of pressure. So there will be solid and liquids phase in equilibrium. So let us consider the two component system of two solids, that is A and B. Okay. A and B. A is a solid and B is a solid. Okay. And these solids are miscible in their liquid phase. Okay. So they are miscible in liquid state. Okay. So this is the y-axis, is the temperature axis. Say this is the melting point of pure A when A it is equal to 100%. Okay. So in the x-axis we are plotting the concentration, and the y-axis the temperature in y-axis. So the graph is like this. Okay. And again, so when A will be 0, B will be 100%. So when 100% B, that is pure B, say the melting point is somewhat here. Okay. Say this is B and this is A. Okay. And when these two solids mix in the liquid phase, are miscible in liquid phase. Okay. Suppose let us consider a container in which we have to take the 80 gram A plus 20 gram B. Okay, and along the x-axis we have to plot. This is the percentage of percentage composition. Okay, so this is percentage composition. So when A is 100%, B is 0%, we can also take a mole percent in this x-axis. For the time being, for easy understanding, I have taken here the weight percentage. Instead of taking mole percentage or mole fraction, I have taken weight percentage. That is 80 grams of A and 20 grams of B. We have taken in the mixture, and as it is marked in the graph, the melting point of A is here. So if we hit the pure A, then it will start melting, and after this will be the A will be in the liquid phase. Then when the liquid phase will be condensed, then at the A this will reach to the solid A. Okay, so this A is the freezing point of A and also the melting point of A. And in the mixture we have taken 80 gram of A and 20 gram of B, and it is heated to a very high temperature, that is above the melting point of A and above the melting point of B. It is heated. So say the temperature is somewhat here. Okay, the temperature is somewhat here. Then after at this temperature, both A and B are miscible, and forming one phase, that is the homogeneous phase, liquid phase, and this liquid is the A plus B in solution phase. So when we cool it, then it will fall to the temperature here. Temperature will fall, and they say at this point it starts solidifying, because we have added the two components. This is A is the solvent. A, we can take it is solvent, and B is the solute. And to know the colligative property, the presence of impurities lowers the freezing point of solvent. So the presence of impurity, the freezing point of A is lower. So at this point we get a solid and A plus B solution. Okay. So this is the temperature where the A starts separating. So in the solution here, the composition of solution is 80:20. Okay, and at this point, when some amount of A gets separated from the solution, the weight of solution is less than 100 gram. Total mass of the solution was 100 gram here, but due to some separation of some solids, the weight of solution is decreased. So at this point, at this temperature and this point, the mole fraction of A and B, it is 80% of A. Okay, it is 80% of A. So in the solution, if we consider the composition is changed. Suppose say at this point some 10 gram of A separates out. When 10 grams of A separates out in the solution, the amount of B is same, and the amount of A becomes 70 grams. So total amount becomes 70 plus 20, that is 90 grams. And the percentage is changed because of the separation of A. The percentage composition is changed to become the A will be the 70 by 90, that is 77.8%, and the percentage of B becomes 22.2%. So say at this is the composition of solid now at this temperature. So this is the solution composition at this temperature, and further if we cool it, then it will be solidified. Separation of A will start at a lower temperature. Okay. Say at this temperature again, say 10 gram of A separates out. So and here this temperature there is equilibrium between solid A and solution. Also at this temperature again there is equilibrium between solid A and solution. So at this temperature the composition of the solution again lowers. That is in the solution say 60 gram of A plus 20 gram, that is of the amount of B remains same in the solution, so it is the total mass of the solution is 80, and the percentage composition is 75, 60 by 80, so it is 75% say somewhat here. The graph I am indicating is not to this scale, so this is 75% of A. So at this point, this is the composition. So at this composition, if we will lower the temperature, say this is this temperature. So at this point, the A will separate. Okay. So at this temperature, some amount of A again will be separated. Say again it is separated 10 grams. So gradually the separation of solid A is continued from the solution, and the weight of the solution is decreasing continuously, and also the percentage composition of the solution is changing. So percentage composition is moving towards the right, and the temperature is falling down. So at a particular composition, say point here, say the solid A and the solid B will start separating. So at this temperature, both A and B start separating. Okay. So this is the minimum temperature at which, and this composition corresponds to here, say somewhat 40. So what say 60 to 40. Okay. So at a composition of 60:40, the A and B both get separated from the mixture, and the temperature remains constant. Okay. So if we connect these points, then it will come to here a curve will be obtained. Okay. So this is the freezing point curve, and the lowering of temperature is according to the colligative property, delta T is proportional to the molality of the solution, and the molality of the solution, B is the solid and A is the solvent. Also the molality of solution is also proportional to the number of moles of solute. As the number of moles of solute continuously increasing in the solution phase due to separation of A, the freezing point is continuously decreasing, and at a particular point when it is reached, okay, then at that point both solid A and solid B separate out from the solution, and this point is called the eutectic point. So eutectic means the easy melting or the lower melting solution, lower melting mixture. Okay. So this is applied in your metallurgy, the extraction of metal. Suppose A is a metal, B is a metal, and B is considered the impurity to the metal A, and we are interested in separating metal A. So in the solution there is continuously formation of a solid A, and that solid A can be taken out. And this temperature is called as a Eutectic temperature, Eutectic, and this composition is called the Eutectic composition. Suppose you will take the Eutectic composition, say 60% A and 40% B in the solid. So 60 gram of A and 40 gram of B, then it is heated to a very high temperature, so somewhat here, and if we cool it, then it will be at this point where it will be separation of A and B will be made separate. Okay, so let us consider again briefly. So we have taken in the container, this is the AB solution. Okay, so we have taken this amount of A, 80 gram, amount of B, this is 20 gram, total weight becomes 100. So 100 grams we have taken, and it is heated to a very high temperature. So this is A, and we have not considered B here, only we are considering A. So this is the melting point of A, and this is heated above the melting point of A and melting point of B. It becomes homogeneous and single phase solution. So due to presence of impurity, when it will be cool, say it will be somewhat here. Okay, the cooling will be somewhat here. The percentage. Okay, so this temperature, say this is 150 degrees centigrade. Let us take the numerical value for understanding. The 150 degrees centigrade, it is the melting point of pure A. So when 20 gram of B mixed to the A, the melting point will be, say, here it is 140 degrees centigrade. So at 140 degrees centigrade, the freezing point of A. So at this point, A will be equilibrium with the solution. Okay, and here some solids of A are formed. Say this composition corresponds to the 80%. 80. A is 100 we have taken. Okay, this is percentage composition in the x-axis. Okay, so we are indicating only the composition of A. So at this the solution, when some amount of A separated from the solution in the form of solid, the composition of solution changed to, say we have taken 10 gram of A. So when it is cooled, some amount of A separated out from the solution. So the weight of the solution becomes 70 plus 20, that is 90, and the percentage of A is 77.8. So this will be the composition of solution is changed. So 80, so it will be 77.8%. So at this composition, the freezing point will be, say, further lower to say this temperature, say 135. Okay, 135 degrees centigrade. Again, at this 135 degrees centigrade, the solid, some more amount of A will be solidified, and the content of the solution will be decreased. Say each point there is 10 gram of A is getting separated. It is not experimental. Experimental value may be somewhat else. but for theoretical understanding, I have taken each installment, there is 10 gram of A gets separated out. So further the A becomes 60 gram in the solution and B 20 gram and total weight 80. So the percentage becomes percentage of solution will be at this 135 degree centigrade, that will be say here, that is say 75% of A. Okay. So when 75% of A, we will collate the molality of solute increasing gradually. So the freezing point will fall according to colligative property. So the freezing point is somewhat here, and some amount of solid will form, say 130 degree centigrade. Okay, and again the composition of when again the 10 gram of A is separated out, so the weight of solution is continuously decreasing, and so also the percentage composition, and the 50 gram of A and the 20 gram of B, so the total weight becomes 70 gram, and the mole fraction, mole percentage of the weight percentage of A, that is 71.4. Okay, so at this point the composition of solution is somewhat here, that is 71.4%. Okay, so at this point the freezing point will be further lowered, say to this temperature. Okay, so this is 125 degree centigrade. Okay, so again at 125 degree centigrade, some more amount of A will be separated out, and same amount, say 10 gram, and the mole percentage of the solution, mole percentage of the solution will be less. Say 40 gram of A in the solution and 20 gram of B in the solution. So the percentage composition becomes 66.7 and 33.3. So say somewhat here, that is a 66.7% of A in the solution. So the freezing point will be somewhat here. Okay, so freezing point will be somewhat here, and say 120 degree centigrade. Okay, so the freezing point of A is continuously decreasing, and the molality of B is continuously increasing. So at this point again the some amount of A gets separated out, and the content of the solution is decreased. Okay, so the mole fraction or the mole percentage of A and B again varies. So 120 degree centigrade, the solution will have 60 into this to 40. Say we have reached a point solution composition that is here, that is 60% of A and 40% of B. Okay, and as I have pointed out, this is the composition, but at this composition the freezing point will further lower, say to 115 degree centigrade. Okay, so it is 115 degree centigrade. Okay, and at this point, what happens? Instead of separation, in addition to the separation of A, some amount of B starts separating. Okay, so when both A and B are solidified out of the solution, this is called the Eutectic point. Eutectic point. Okay, and this composition is called eutectic composition. That is 60% is the eutectic composition, and this is called the eutectic temperature. Okay. So at the eutectic temperature, the both solids get separated, and this eutectic temperature, eutectic point is in equilibrium with here there are three phases: solid A, solid B, and solution. So this is, at this point, three phases coexist. Three phases coexist. Okay, because two different solids are two phases, and the solution is one phase, so three phases are there, and we have the condensed phase rule, that is A is equal to 1 plus C minus P, so 1 plus 2 minus 3, that is 0. So this point is invariant, that is this point is fixed. Okay, so at this point the composition remains same. At this point the composition remains same, and the A and B gets separated out. So if we further lower the temperature, then all the solution will be condensed to solid A and solid B. So at this point, when B starts separating, the composition again will be changed. Okay? So in this way, we are getting different points, freezing points. In these points, we will get a curve that is called the freezing point curve. Okay? So this is the regarding eutectic. So how a eutectic is formed? How a eutectic is formed? So both solids are miscible in their liquid phase. They do not have any chemical reaction in the liquid phase, and when they are solidified, one of the components gets separated, and the solution is continuously, gradually enriched with the other component. So the percentage composition shifts towards the right. As the percentage composition shifts towards the right, according to the colligative property, the molality of solution is increasing, so it has direct impact on the depression in freezing point. So freezing point continuously gets lowered and lowered. So at the particular composition and temperature, both A and B get separated out, and that point is called the eutectic point. So eutectic means the easy melting point, easy melting mixture. Eutectic mixture say the easy melting mixture. Eutectic point, easy melting point or lower melting point. Suppose we will take a 40 gram B and 60 gram A in the container, and we will heat it. Then it will melt at 115 degrees centigrade. Though the melting point of A is 150 degrees centigrade and B is somewhat higher than A. Okay? So this is the beauty of forming eutectic. So whatever this is mainly applied in the metallurgical extraction in the industry. So in the solution we are getting continuously, we are getting more and more solid A. So if you are interested in the solid A, we can take it, and there is a continuous equilibrium of solid A and solution. Okay, and as the A separates, the composition changes and the freezing point changes. So this is called the freezing point curve. So in the next video we will consider the eutectic diagram of both the components. So I don't want to make this video a lengthy one. So at this point you must have understood what is the eutectic and how it is formed. So thank you for watching, and give your comments and share and subscribe to my channel for